Okay, so now let's look at how we construct a histogram here, and that would be the topic in 2.3. And notice histogram is the only topic in section 2.3. Okay, so now constructing a histogram is basically constructing a visual display of a class frequency distribution. So now taking on the class frequency distribution we had earlier for data 1. So this is data 1 we're looking at, and here's the class frequency distribution. And notice that on this particular chart I'm using class width 10. So once again, here these are all my classes, and these are the corresponding frequency for each classes. So constructing a histogram is just basically getting for yourself another bar graph. Once again, you getting for yourself a bar graph. Now you're gonna put all the classes, you're gonna lay down the classes along this horizontal axis right here. And then this time make sure you put the classes adjacent to each other, no space in between. So now that first space right here would represent 60 to 69. The second space right here would be 70 to 79. And once again, each class is acting as a category. It's being treated as a category. So here I have 80 to 89, and here I have. So try your best to make these little space here as equals as possible. So I'm making these categories here, these widths here equal space. 100 to 109, and here I have 110 to 119, and the last one I have 820 to 129. So those are all my different classes. So keep in mind, once again, class go on this. These are all the classes. All the classes got laid out on the horizontal axis. So now once again, the vertical scale here, the vertical axis is going to represent the frequency. So you're going to put the frequency here. And once again, if I notice on my table 14 would be the highest one, so I would go this time I would go about 20. That gives me a 10, and there's a 5, and that would be a 15. Okay, and there's a 5. So those would be my scale so far. So now the first class from 60 to 69 and have a 12, so slight about 2 units above. So you can, like I said earlier, histogram is simply bar graphs, but this time I want my bars, my vertical bars, to be precisely adjacent to each other with no gaps in between. And once again, it's always a good idea to fill in the to shade in the graph. So that's for my first bar right here with scale 12. My second bar is supposed to be adjacent, or is supposed to leave no gap in between the two classes here. So my second bar has height 14, which is slightly below my first one. And here's my class that represents, here's the bar for my class from 70 to 79. And then it comes to 80, slightly above 10, because it has 11. Once again, you can see, and of course if we have a ruler, that'd be good, because we can be more precisely on scale, but that's for illustrative purpose once again. So the third class from 90 to 91, I have only one, so that would be down here, maybe even a little lower than that. Okay, and here's, you can shade your histogram. From 100 to 109, I have frequency 1 once again, if you read on the chart. And here notice the class from 110 to 119, there is 0 members. There are 0 members, so that's simply height 0 on the scale. And here's the last one. Here we have a height 1 again. So, and then Now, maybe we don't have to do this for now yet, but it's worth to mention because later on we're going to need it anyway. Now, so for now we call that for fancy purpose. Now, for each of these rectangular bar on the histogram, we take the midpoint, or roughly the midpoint, on each of these rectangle, and now I'm going to connect these points right here, and later on these point is going to be, at least these points is going to give me an idea of how the shape of the overall data, the shape of the overall distribution looks like. So once again, that's how we construct a histogram. The overall histogram here is telling me how the data is distributed. Now I can see that now with this visual display, now I can see that data is more focused on the area where data is going ranging from 60 to 89, and then it's much spaced out, and in fact areas have much less in these areas right here. So now that's how we construct the histogram. Back to the questions that earlier, that what about when you create the histogram in other widths? So here, let me demonstrate the idea to you once again. Now if you now look over to my Microsoft Excel data, I'm gonna put all these histograms here on the Microsoft Excel charts again. So if you can observe right at my first screen right here, this is my frequency distribution for class width 10, which is what we just did, and here's the histogram, and that was constructed by Microsoft Excel, and here's the kind of shape that we have. So we're expecting something just like what we did earlier by drawing it by hand. So it's something just like what we draw by hand just earlier. So now what happened if we are using we are still on data set 1, but we're looking at class width 5. We're constructing a frequency distribution for class width 5, and here's supposedly how it looks. So I have classes from 60 to 64, from 65 to 69, and 70 to 74, and so forth and so forth. And here is the histogram for class width 5 right here. And that's how it looks. So as you can see now, comparing between the two histograms, the histogram for class width 10 and histogram for class width 5, of course we have in the histogram with class width 5, we have more accuracy. We can know a little better detail about in particularly which interval range give me more data concentration. But still, the general idea here is that in between 60 and 89 we have more focus of the data, and whereas here in these area right here, even in some classes there are just even no members at all, and data kind of scatter out and spaced out on these areas right here. So now what happens if we try with class width 20, if we reconstruct our distribution using class width 20, and we have even less class, we have only about 4 classes this time, unlike the other case. So, and if you observe the histogram here, the number of rectangular bars is just, we're losing lots of frequency, we're losing lots of accuracy this time. And so what you can see here is that as a general rule, so now if you're doing larger class width, so that's one of the general rule, larger class width means, now my double arrow right here is a notation for logical implications, or it's means. So larger class width means less bars, okay, or classes or columns, whatever you want to call it, okay, and that also means the same as, that implies, or it means the same as less accuracy. Okay, or some people might prefer to say less precision. Okay, so the larger the class width, the less precision we're gonna end up with. But then generally this would be, but for us it's less effort, because it's less efforts to draw the bars. So so it's a good thing for us. Larger class width, less effort for us, but then it implies that less bars and less accuracy. Now, if you're looking at smaller, if you decide to construct your histogram with smaller class width, okay, then what's going to happen here is that we're going to have more bars or more columns or more classes. Okay, and then that also means we have more or better accuracy. Okay, and then but then the cost for this is, when you have smaller class width, the cost for that would be we have to spend more effort, we have to spend more time to constructing the histogram and all that frequency distribution. So how do we decide? So basically here you have to choose smartly when you're in your real field. Choose or decide smartly a class width for yourself. For yourself when you're doing it on your own. Okay, so basically the idea is you don't want to choose something that costs you too much effort, even though it has really good accuracy, but you don't want to, do something that costs you too much effort. But you neither would want to do anything that costs, you neither want to do something that with too large of a width, because you're going to lose all that accuracy. So choose something good in between, and that's the idea of how you can construct a histogram, and along with the class frequency distribution.